what we're looking at in this video is network communications, and in particular we're looking at IP, which is Internet Protocol communications. And so let's just get a broad overview of what's going on when we communicate using IP. So a sender computer will have an IP address, which is a bit like a telephone number, and the destination computer will have another IP address, which is a little bit like a telephone number. And these are unique numbers to each of the computers. And so if I try and send information, each of these dots here is a different computer or a different router, and they will each have their own IP addresses. And so I send on to each of these computers, and they then forward on until it reaches the destination computer. And so what is it sending? It's sending things called packets. And so it takes a large amount of information and it will then split that up into smaller amounts of information, and each packet is a group of bits which will contain the destination address and the data itself, and it will also have the address of where it came from. And so if we look back at our network here, it's possible, once I split it up into packets, one packet, the first packet might go through here, and then another packet may decide to go through a different part of the network. So if this line here was overloaded, there was too much information, or maybe one of the links got severed, then it would be possible to send that packet through in a different route, and packet 2 may go through that way. Now let's look a little further at these things called IP addresses. So an IP address, and remember IP stands for Internet Protocol, so the protocol is the way that these computers on the internet communicate with each other. So IP addresses contain 4 numbers, and each number can be from 0 to 255, and as we know, that's 8 bits. So what we have is 8 bits for each of our numbers. So in total, the number for an IP address is a 32-bit address. So I could write that with zeros and ones, 32 zeros and ones. Normally we write IP addresses much more like this, using denary numbers between 0 and 255. So this would be a valid number. Equally, a valid IP address could be this number here. No computer would be given this name because it's got a different meaning, but it is an IP address. Equally, you could in theory have 0000. Common IP address which you may hear of is 127.0.0.1, and that's reserved for your own computer. So if you ask something to ping itself, then if it's 127.0.0.1, that's the home computer, that's the same computer as you're using. We can look at what these IP addresses are instead of domain names, and so if I use a command called ping, then I can say ping www and then a search engine, and what will come back here, it's doing something called ping, so it's requesting that the person I send to sends me a quick message back, and then it's recording how long that message takes. But the important thing here, what we see here, if with this number 74.125.230.144, this is the IP address of google.com. And so it's told me what the actual IP address, like a phone number, is for that computer. So that's what the IP addresses are. And then we have another thing called a MAC address, and MAC stands for a Media Access Control. And this is a slightly larger number. So the Media Access Control number or address and the MAC address is a 48-bit number, which means there's 281 trillion possible numbers we could use. So 48-bit number, and we normally represent it in hex, so 2 digits of hex and 6 times. So a total of 12 digits of hex. And what this is a unique number for each network interface. So if you've got a network card in your computer, that will have a unique MAC address. If you have a wireless card in your computer, that will have a unique MAC address. Your phone, if it's an internet-enabled phone, will have a unique MAC address. So this is unique to not only every computer, but every single interface card or interface within a computer system. And it's a little bit like a serial number in that the manufacturer of the card imprints what the unique number, the MAC address is for that card, and that MAC address can be read by the computer. So it's a bit like a serial number. And also it can be used within a Wi-Fi system, so it's possible on Wi-Fi to block MAC addresses and then maybe only allow through certain MAC addresses. So then we're allowing certain computers to access our network, so it can be used for security. It goes a little bit further than that though. It does a little bit more, and we'll look now at how these packets really work inside. And so what we have is some data to start with. So that could be text, or it could be an image, or it could be an executable file, whatever we're downloading. So we start off with some data. And then that data gets split into packets. And before it gets split into packets, it gets divided up. Then the data gets put into the packets, and we'll just explain a little bit of what's going on here. So each packet contains a header at the front and then the data afterwards. So this would be on my first packet, and then my second packet, and my third packet. And in that header data, what we have is the destination IP address and also the sender IP address. So every single packet in this header will contain my destination and my sender, and then the data will follow. And then what happens, lower down, is each of these Internet Protocol packets, so each of these IP packets, so what we have here is our first packet, then gets put into what's known as the payload, and then there's now created an Ethernet packet, also known as an Ethernet frame. This one contains the MAC addresses. And so this will be the sender and the destination, and this will be the MAC address inside this part here. Now let's take a look at an example of how my IP packet and my Ethernet frame can get built up in order to send the whole packet across the network. So what I have here is I've got a sender computer here, and it's got its IP address here, and it's got its MAC address here. And then I've got a destination here, and that also has an IP address and a MAC address. And so let's say that I want to send some data that says data. So first of all, I've got my data, which will fit into the packet. So I've divided up my data so that it can fit into one packet. And then I need to tell it what the IP address is for both the sender and the destination. So in this case, it will know that the sender is 158.122.168.0. And so this is going to fit into my IP packet. And the destination is 177.22.55 and 12. And so all of that together is an IP packet with the header and the data. And then it needs to send from this computer to this computer before it can get all the way over there. And so at that point it's going to say, I need to know what the sender and the destination is for the MAC addresses. So the sender is A72218CDFE0F. And the receiving computer is this one here, which is C25822185556B. And that there, which is the whole thing, is an Ethernet frame or an Ethernet packet. And so it's now able to send all of this from this computer to this computer. Once it reaches the second computer, or it could be a router, then what that router's or that computer's going to do is it's going to get rid of these numbers here because that's no longer the same. And so now it's going to say the message or the packet is at this point here. So it's now going to say that we're going to take this MAC address here, which is C2. So this becomes the sender MAC address, 2218.55.6b. And now it's going to send to the next computer, and that's got the MAC address there, so that will be the destination A959BC E2FA C7. And so the MAC addresses keep on changing, the sender and receiver, as it goes through the network, so that Ethernet frame changes, but my IP packet always remains the same. And my IP packet is always saying this was the original sender and this is the final destination. So my IP packet remains the same as it travels through the network. My MAC addresses will change as I go through each of the computers or routers on the network. And MAC addresses are in order to get from one computer to the next computer. And so your personal MAC address never goes further than the next computer on.